Hello everyone. After understanding all the previous concepts related to acidic comparisons in phenol, we are in a condition to understand acidic comparisons. Different phenolic compounds I will take and I will compare their acidic nature. In this video, we will compare these four compounds' acidic nature. Compounds are, this we know, it's a normal phenol. This is ortho-nitrophenol, because you can check this is ortho position, nitro group is available, so this is ortho-nitrophenol. If I talk about IUPAC naming, OH will work as a main functional group and NO2 will work as a side chain. So numbering if I will provide, so this will be first number, this will be second number. So 2-nitrophenol will be its IUPAC naming. Next is meta-nitrophenol, which you can call 3-nitrophenol. Next is para-nitrophenols, which you can call 4-nitrophenol in IUPAC naming. The topic is present in 12th class syllabus, JEE, NEET and BSc also. Let's start comparing their acidic natures. You know, we can compare acidic natures by two ways. There are two methods. Number one, check OH bond strength. Or second, check stability of anion left after release of H positive. I am going to apply this second method. From both methods, answer will be right, order will be same. I am applying here second one. Anion I will make and I will check its stability. So how to do it? Please check. First we will write all the compounds. Phenol, ortho-nitrophenol. Nitro group is in this condition. Meta-nitrophenol. And para-nitrophenol. Now because I am going to apply second method, so first I need to make their anions. After release of H positive, you know electrons will transfer toward oxygen because oxygen is more electronegative than hydrogen. So anions will generate. Let's make their anions. Already oxygen was carrying 2 lone pair, the third will come on it. So total 3 pairs of electron will be there and oxygen will carry a -1 charge because 1 electron is of hydrogen here. Now I will check which is most stable anion. Let's start to write the factors which are present here. Factor number 1. You know this anion is able to show resonance. Which atom is unstable here? This oxygen is unstable because it is carrying a lone pair. -1 charge it is carrying, extra lone pair it have, -1 charge, so it is highly unstable. Now we will check which factor can make it stable or destable. First factor are normal resonance. The whole resonating structures I will not draw. I will just draw which I need. Already I have discussed these structures with you, so please make by yourself. I will just write factors here. This will be the next structure if I draw resonance of it. So you can check through a resonance of oxygen, its negative charge is finishing. And this resonance is available in all cases. In all cases, we have this factor. Means normal resonance of oxygen, or you can say plus R effect of oxygen. This oxygen will make it stable because its negative charge, you can watch, it is getting finished, and it is available in all cases. So plus R of O, which is also available here, plus R of O, plus R of O. Here also we have plus R of O. All those four cases have plus R of O. Okay, next factor. Nitro group is available. On which position? Ortho position. In previous videos, I have already told to you, from ortho position, nitro group will absorb electrons. Which effect it will? It will be a minus R effect. So here I will write minus R of NO2. From meta position, you know, nitro group can't absorb electrons which are coming from resonance. Means from meta position, it is not going to show minus R. So here, no need to write it. From para position, minus R effect of nitro group will be there. Check previous videos, you will understand it. From ortho and para position, nitro group can absorb electrons which are coming from resonance. So we will call it minus R effect. So from para position also minus R effect is available, minus R of NO2. Here we don't have that effect, here we don't have that effect. Third effect. In this, only one effect is there, plus R of oxygen, which is visible to us here. Now, as you know, nitro group is more electronegative than carbon. So obviously it will attract electrons due to electronegativity difference. This effect is known as minus I effect. Means nitro group will absorb electron during resonance as well as due to electronegativity difference. So here one more effect is there, minus I effect. NO2 group, nitro group is attached to carbon, and nitrogen is more electronegative than carbon. So obviously it will attract electrons due to electronegativity difference. Same like here. So here also we have minus I effect of nitro. And here also we have minus I effect of nitro. So students, always first write down all the effects which are present here and then start to compare them. Which is increasing the stability, which is decreasing the stability. Let's check. Number one, this factor. Plus R effect of oxygen will decrease the negative charge of oxygen or not? Yes. Means it is going to stabilize the oxygen. It will increase the stability. Because these all four factors are present here, so only this factor can't decide which is more stable, which is less stable. Okay. Leave it. Go for second. Minus R. Minus R effect will increase the stability of anion or decrease? It will increase the stability of anion. How? Because when it will absorb the electrons, it will increase the timing of a finish of a negative charge. In previous videos I have told you. Please check them. So here minus R of NO2 will try to increase the stability. In meta it is not available. In para it is available. Okay. So if I say it is increasing the stability, it is increasing the upward arrow when I will write means it is increasing the stability. It is increasing the stability. It is also increasing the stability. Here it is also trying to increase the stability. It is also trying to increase the stability. Okay, come to here. In this case, substituent is not available, so minus I effect of substituent is not there. Here we have nitro group as a substituent. It is showing minus I effect. What is minus I effect? Means it will absorb electrons due to electronegativity difference. So don't you think if it will absorb electrons like this, so as this carbon will lose electrons toward nitrogen, it will become positive. In turns, it will start attracting electrons from this carbon. In turns, this carbon will little bit start attracting electrons from the oxygen side like this. Little bit, not too much, little bit. Due to this attraction, negative charge of oxygen will decrease. Yes. So minus I effect of nitro group is also trying to increase the stability of anion. Here also this effect we have. It is also trying to increase the stability. And here it is also trying to increase the stability. Now listen very carefully. Whenever you are checking I effect, and I already told to you, I effect depends on distance. Now, nitro group is very close to oxygen. So here minus I effect of nitro group is felt by oxygen strongly. So you will say, in this case we have strong minus I effect. Now as distance will increase, the minus I effect will decrease. In this case you will write weak minus I effect. And here weakest minus I effect. That's it. Everything we have written about the effects. Now it's a time to just conclude it. Okay. So please check in which anion the negative charge is decreased highly. In which case the negative charge of oxygen is decreased highly. I believe this is the second case. It's the second case. Let's number them. First case, third case, and fourth case. Check here. The negative charge of oxygen is decreased by three factors: plus R of O, minus R of NO2, and minus I of NO2, and which that minus I is strongest here because NO2 is closest to O. So I believe the negative charge of oxygen is decreased most in second case. So don't you think this is most stable anion? These three factors are available in para case also, but para case is lagging behind only due to minus I effect. Check. These two effects are similar, but minus I effect is weakest here as compared to this one. It is strong minus I effect and it is weak minus I effect due to distance. That's why this group is lagging behind as compared to this in terms of stability. Okay, so this is most stable, and after this, if I talk which is more stable, after this, after second you can check, the fourth will be more stable. Check, because the negative charge of oxygen is getting decreased by three factors: plus R of O, minus R of NO2, and minus I of NO2. Check. So if I start to write roughly increasing order of stability, the second will be most stable, fourth is less stable than second. Okay, if I compare first and third, which is most stable, the third is getting stability due to two factors, plus R of O and minus I of NO2. Whereas first is getting stability only due to one factor, plus R of O. So clearly visible, the third is more stable than. So first your duty is to get this rough idea. This is the stability order of the anions. That's it. So if this is the stability order, so what conclusion we will draw for acidic nature? This molecule after loss of H positive, this was the molecule, ortho-nitrophenol, after loss of H positive is getting most stable anion, means it is in a most benefit. So definitely it will release its H positive very easily because it knows that after loss of H positive, I will get most stable anion. So if it will release H positive very easily, so it will be a strongest acid. So this was the stability order. Stability order of anion, increasing order. And if I write now acidic order, so it will be same. The second compound means ortho-nitrophenol will be most acidic because it knows that after loss of H positive, I will get the most stable anion. So it will be ready to release H positive. And if it is ready to release H positive, it will become most acidic. Followed by fourth one. So out of ortho-nitrophenol and para-nitrophenol, ortho-nitrophenol is more acidic as compared to para-nitrophenol. Okay. Then third, meta-nitrophenol, and then least acidic will be normal phenol. Because normal phenol know in comparison of these compounds, if I will lose H positive, I will get a unstable anion, most unstable anion. So it will delay to release H positive, and delay to release H positive means the compound will become less acidic. So this is the acidic order. In this fashion, all the acidic comparisons you will solve. It's your choice. You want to use first method, check the strength of OH bond, or you want to use second method, check the stability of anions left after H positive ion. I have used this one. Try first method by yourself also and you will get the same result. Now this concept is not over yet. This is the acidic nature. Ortho is most acidic, followed by para, then meta, and phenol is least acidic. This is the order which we got from our basic knowledge. But always we have some exceptional cases. Be careful with those exceptional cases at any level, whether it's 12th class or whether it's competitive level. What is exceptional cases? Exceptional cases always you will write down separately. Here we have exceptional case. This is right, this is right, no problem in them. Here we have problem. What is exception? Exception is this. Para-nitrophenol is more acidic than ortho-nitrophenol. This is exception, note down. Let's go for the reason now. Whatsoever the exceptions will come, I will tell you separately. And make a separate note for exception. Exceptional acidic nature. Yes. This is ortho-nitrophenol. And this is para-nitrophenol. Nitrogen plus one charge. Now the problem is, in ortho-nitrophenol you can check oxygen is there. Oxygen is more electronegative than nitrogen. So obviously these electrons are toward oxygen side. So oxygen is carrying partial negative charge. This oxygen is carrying partial negative charge. This oxygen is carrying complete negative charge. So this hydrogen, which is carrying positive charge, because it is connected with oxygen, its electrons are toward oxygen side. It is highly positive. So this positive and this negative have some attraction, due to which this hydrogen will be holded by the oxygen and release of H positive will become difficult. This bonding which is generated between oxygen and hydrogen is known as intramolecular hydrogen bond or bonding. Due to this intramolecular hydrogen bonding, release of H positive will become difficult. This is the point. This is the exception here. And you know, if release of H positive will become difficult, it will become less acidic. Such problem is not there because this hydrogen, positively charged hydrogen, and this negatively charged oxygens are far away from each other. So such interaction is not possible. That's it. That's why orthonitrophenols are less acidic as compared to para-nitrophenol. So the final order will be this. First was phenol, third was meta-nitrophenol. Now here second will come and fourth will be more acidic, most acidic. Means para-nitrophenol will be most acidic. Orthonitrophenol will be less acidic than para-nitrophenol, but it will be more acidic than meta and normal phenol. That's it. That's it in this video. This is the first comparison, and this is the way in which you have to do comparisons. Now next comparisons in next video. Thank you very much.